is, I think, a really nice animation of how the subduction zone works. So it's kind of flipped around backwards, unfortunately, but this is Japan. So you're looking from the north towards the south.
The initial quake, measuring 8.9, struck just off Japan's east coast.
Every Friday, seismology students at the Lamont Doherty Earth Observatory meet with their professors to debrief about the week's seismic activity. Typically, it's a handful of students. Today, it's a room full. On this Friday, the most powerful earthquake ever to hit Japan triggered a 30-foot tsunami. The quake was one of the world's 5 strongest in more than a century of record-keeping, with a magnitude of 8.9. Earthquakes occur when the outer layer of the Earth's crust, which is broken up into large plates, meet. The internal heat of the Earth is constantly causing these plates to shift and move. Sometimes they collide and then stick.
And so you can kind of think of compressing a spring. And so the crust that makes up Japan is being crushed by this plate moving in from the east. The Pacific plate is pushing into it, and it's basically compressing it. It's a spring that's being compressed. And at some point, the friction that's holding that spring in place slips and it releases, and boom, it pops back.
The result can be a tsunami that travels across the ocean with the speed of a jet plane. But the full power of a tsunami is demonstrated as it approaches shallow waters.
So in the deep ocean, you have only a very little ripple of a tsunami, so nobody can actually realize it. When you get close to the shore, this whole energy gets piled into this wedge. And so the tsunami gets higher and higher, and that's what happens when then the tsunami waves come ashore.
According to James Garrity of the observatory, earthquakes of this magnitude are so rare that scientists have a unique opportunity to study what caused these megaquakes. Japan's long and detailed history of documenting such events will also help seismologists to identify patterns that lead to large-scale quakes.
So one of the really big questions associated with them is, does the pattern of smaller earthquakes in the area where smaller earthquakes occur provide some information on the likely areas where these big magnitude 9 earthquakes are going to occur? Earthquakes of many sizes are occurring on faults all the time, and so over time, do you build up a systematic pattern of where the biggest events are relative to slightly smaller events, and therefore in some ways is that going to be predictable in the future that we might expect more earthquakes of this size over the next century or so in Japan and in other regions.
Scientists say Japan is at the forefront of earthquake science. It developed the world's first early warning system that helped alert people in Tokyo before they felt any tremors. Still, Mr. Jacob says we're a long way off before we can accurately and reliably predict earthquakes.
You can't build a scientific base on individual successful cases until they can be multiplied and make up the majority of the cases. That is to say, earthquake prediction is still a long time away. Whether we ever will get there is not even clear, even with the best instrumentation that we have.
For the Wall Street Journal, I'm Christina Sui.